Okay, so this example we were discussing in last class. Okay, so here what you are observing, you are observing that mean is same. Okay, and we were discussing about the how to check the variance. Okay, how to check the deviations. Okay, so here what is important? Important is the deviation. Okay, although you are having the same mean, but thing is that deviation is there. Okay, now can you tell me how to find? So here for the all the three cases you are having the same mean. Here also you are having same mean. X bar same 200. Here also third case x bar same 200. Okay, all the three cases you are having same mean. Okay, now can you tell me how we can deal with the situation such a way that we need to calculate the deviations. Okay, what we need? We need to calculate the deviation from these three examples. You are what you are realizing? You are realizing that deviation is there. So first one, how much deviation is there? First one, series A, how much deviation is there from the mean value? So you are saying that the class average is 200 and all the values are same 200. So any deviation is there? Mean is nothing but the average value. Average means the expected value. Okay. So when you are saying the class average is 30, so it means that almost each and everyone's mark is almost close to 30. So here the class average is 200 and everyone is having 200. So how much is the deviation here? Series A. Hello.
0.
0 deviation is there. And series B, now you can see that how much deviation is there. So deviation is there or not? Series B. First one, there is no deviation. Okay, there is no deviation. The average value is same as the actual value. Okay, the expected value is same as the actual value. Okay, first one, no. Second one, deviation is there or not?
Yes, sir.
Right?
5.
Yeah, obviously it is there because you are saying that class average is 200, but value is at 205. So here 5 deviation. The first data is having no deviation. Here 2 units. Here 3 units. Here 10 units deviation is there. But thing is that if you are calculating 200 minus 200, here 0. If 205 minus 200, then here 5. Here 202 minus 200, then here you are having 2 units. Okay, and here you are having 3 units, and here you are having minus 10 units. Okay, so how to deal, how to calculate the deviation? How to calculate? If you are taking this sum, then here also another issue. This minus and this plus may get cancelled. This may give you the 0 deviation. Hello, getting or not? Hello, hello.
Yes, sir.
Are you understanding what I'm saying? See, this minus and this plus. So if you are adding everything, so it will give 0. But whether you are having 0 deviation, no. Actually, you are having so much deviation is there. So how to deal with that?
Modulus.
You can take
Modulus.
you can take module, that mod what you are saying that is correct only. You can take square also. If you are taking square, everything will be positive. Correct or not? So in mod wise also you can take, that is one way. Another way is that we can take the square. Okay or not? Correct or not?
Yes, sir.
And after taking the square of the error, these are the error terms or not? These are the error terms or not? So we have to take the square. After that, what we need to do? We need to find the average deviation. The sum here you are calculating the sum of the square of these error terms. Okay, all will be positive. If you are taking the square, all will be positive, but that will be the sum of the error. But we need the average error. How each unit is deviating from the mean, how each data is deviating from mean, how we'll get? By taking the average of that, average of the square of the error. Getting or not? Hello. So if you're taking square everything, so this is 25, this is 4, this is 9, this is 100. So you just add everything. After that, what we need to do? We need to take the We need to take the average. If you're taking average, then what you'll get? You'll get each data, how much it is deviating from the mean position. Getting or not? Hello?
Yes, sir.
So we need to, first we need to find the deviation, then we need to take the square of that, then we need to average it. Correct or not? If you're taking the average, then only we'll find the, what we'll get? We'll get the per unit data, how much it is deviating from the mean position. Okay. So that one is called as the variance. So what is the variance? Let me show you the definition here. So mean deviation we were discussing last class. Okay, here. So here, that is called the variance. So here variance, what you can see. So this is xi is nothing but your actual data. Xi is nothing but your actual data. What is x bar? X bar is your mean position. So xi minus x bar, what is that? What is this term? Xi minus x bar. This is nothing but the error term, na? For the how much it is deviation happening. Getting or not? Hello?
Yes.
Hello?
Yes, sir.
Correct?
Yes, sir.
And if you are taking the square means all will be positive. If you are taking square of that, if you are taking the square of that, all will be positive. Correct or not? If you are taking square, then we need to average it by dividing with the total number of observations or total number of data. Correct or not? So this is nothing but the average error. And yes,
So sorry, I couldn't hear what you said. Is x bar the position of mean or the mean value?
mean only. X bar is a mean your average, like that case, na, that 200, that example, na.
Yeah.
X bar
Okay,
is,
sir.
X bar is your 200, your mean only, okay? And xi is the your actual data. So xi minus x bar is nothing but the error, the deviations, how much deviation is happening, okay? Some case you are having some 5, 4, 2 here, some minus 10 was there, something like that, eh? So the how much deviation is happening, then you take the square, everything will be positive. Then you need to divide with the total number of observation. You will take the, you will get the average error, okay, or the average deviation from the each data, and that is called as the variance, and it is given by sigma square. Getting an, and you can simplify it little bit more, okay. You can simplify it little bit more. What you can simplify? You take, so this is a minus b whole square, okay. You just expand this one. So what you will get? So 1 by n into, what you will get? Now tell me, what is a minus b whole square? A square plus b square, then minus
10 to x.
2ab. Correct or not? This is the formula, na? Now tell me, x bar is a constant or it is a variable? For a given data, okay?
Constant.
For a given data, for example, some 10 data are there, x1, x2, x3, x10, 10 data are given. So x bar, so is a variable, like x is a variable. So x bar is a variable or a constant for a given data? For a given data, the mean is constant or it will vary?
Constant.
It is constant always. Okay. So xi is a variable, it will change. Okay. X1, x2, x3, x4 like that. Okay. So what you can, so this constant, so here, oh, sorry, here one summation, some symbol is also there. Eh? Sum of there. Okay. So here 1 by n. So this is nothing but, what is that? So if you are taking this sum inside, what you will get? You will get, let me open the bracket also, eh? Directly on this. So if you are taking this sum and 1 by n, so first you will get, what first term you will get? Sum of xi square divided by n. Correct or not? Then x bar is a constant. So x bar square is also a constant. If x bar is constant, x bar square is constant or not?
Yes, sir.
And this
Yes, sir.
x bar square, how many times you are adding? How many
N
times you are adding?
capital N.
How many times? Hello.
N
How many times
capital
you are
N,
adding x bar square?
capital N times.
You are adding n times if you are having n data. That is why here capital N is there. Na? N number of data is there. Okay. So you are adding how many times? N times you are adding. So what it will be if you are taking the summation inside?
N into x bar
N
square.
into correct only because this is constant only. So I am adding this constant how many times? N times. So this will be n into x bar square divided by n. Correct or not?
Yes, sir.
Then here x bar is a constant. So x bar is constant means here I can bring 2 x bar by n. I can write. Okay, so no need to take n here outside. So 2 is a constant. Minus 2 is constant. X bar is also constant. So what is remaining? Sum of xi divided by n. Correct or not?
Yes, sir.
And sum of xi by n. What is that? What is this one?
X bar.
This
X
is
bar.
nothing but
Me.
x bar only. So here, so this is nothing but your x bar. So the last term will be minus 2 x bar square. And here the middle term is x bar square. So x bar square minus 2 x bar square, what you will get? So let me write this one. So this is nothing but sum of xi square by n. Then, so x bar square minus 2 x bar square. So let me write here. Because the people will get confused. So x bar square minus 2 x bar square. Correct now? Okay. So from here what we will get? We'll get what we will get? X bar square minus 2 x bar square. What you will get?
Minus x.
Minus x bar square only. X bar square minus 2 x bar square. What you will get? You will get minus x bar square. And what is that? This is nothing but sum of xi square by n. And x bar is nothing but, what is x bar? X bar is nothing but sum of xi by n. You know that. So this I can write as sum of xi by n whole square. And this is the same formula here. Getting or not?
Yes, sir.
So either you can use this formula, okay, or you can simplify it. So if you are having xi is given, then no need to calculate the x bar, okay, no need to calculate the deviation, then again no need to take the square. So you just take the sum of xi square by n, then sum of xi by n you calculate, then you take the whole square. And all these things are same only. That is what we have written here. Same thing. This is nothing but this one. Understood or not?
Yes, sir.
Yes, sir.
Anyone need, so whether I need to explain it again? Anyone having doubt? This is very simple one, okay? So if you're having a doubt, you can expand it and you will get this one. Okay. So now for the continuous, if the continuous means if it is discrete or continuous, if the frequency is given, means the x1 is repeating f1 times, x2 is repeating f2 times, xn is repeating fn times, then what you need to do? Just you need to multiply the f5. Correct or not? The same thing what you were doing here, the discrete data, but there was no frequency. Here frequency is coming to the picture. So what do you need to do? Just we need to multiply f5 or not? Previously we are having x1, x2 up to xn. We were now x1 is repeating, for example, f1 times. x2 is repeating f2 times. xn is repeating fn times. Okay, so first data is repeating f1 times. So previously x1 minus x bar whole square you are taking. Now you just multiply. If x1 is repeating 5 times, then no need to do it for 5 different times. You just multiply with 5. Getting enough. For example, 1 is repeating let 3 times. let 2 is there for let 3 times, and let 4 is there, let some 5 times. Okay, so unnecessary na, every time you'll calculate the deviation from xi. So from 1 you will calculate the deviation, from again 1 you will calculate the deviation, from here again 1 you will calculate the deviation. Okay, better you calculate once and you multiply how many times it is repeating, 3 times. So you just multiply 3 into xi minus x bar whole square. Getting or not? Understanding or not?
Yes, sir.
Yes, sir.
So, so if the frequency is given, then you just multiply. So for any case, so when the frequency is given, just the same thing, just you need to multiply F5. Okay. Same to same formula, we are just multiplying the F5, same to same formula, nothing else, nothing different. So you can see 1 by n F5 into xi square, then 1 by n F5 xi whole square. Same to same, everything is same. And that if you are calculating with respect to step deviation, then you can take the di, the same formula. Okay. There is another important observation here. Okay. What is that? Another important observation is about the square root of the variance. Okay. So the variance that we are taking, that is we are taking the square of the error. So if you are taking the square root of variance, that is called the standard deviation. Okay. So standard deviation in our day-to-day life, everywhere we used to use. So you can realize till now that average, only calculate the average won't work. You can recall those 3 examples I showed at the beginning of this class. All the 3 data, they are having same average, same mean, but the data were fully different. First one, there was no deviation. Second one, little bit deviation is there. Third one, there was large deviation was there. Okay, so the mean won't work. Only calculating mean won't work. So you need to calculate the standard deviation. Standard deviation, variance, same thing only. Just if you are taking square root of variance, then you are going to get the standard deviation. Okay. So the same thing, what is the formula of the variance? Then you are just taking the square root of that. Okay, nothing else. So in our day-to-day life, we used to call 2 things. One is the average, another is the standard deviation, because average alone cannot represent your data perfectly. Then you need the standard deviation. Okay, so average and standard deviation we used to call all the time in our day-to-day life whenever we are using the data. So average as well as standard. There is another terminology that is called coefficient of variation. Coefficient of variation, the formula is given like that. Standard deviation, sigma square is your variance and sigma is your standard deviation. Square root of variance is nothing but, so this is your standard deviation. So standard deviation divided by mean, x bar is your mean, x bar is nothing but your mean. So coefficient variation, so in your lab exam also will ask you how do you find the coefficient of variation. Even your lab had interview, that Viva was there, used to be there. So in Viva they used to ask the coefficient of variation formula. Even if the FAT exam or CAT1 exam also they used to ask the coefficient of variation. So this is very important part. One 10-mark question will be, there will be you calculate mean, you find variance, you find standard deviation. Then at the end they will ask you to find the coefficient of variation. Okay, so 2 marks will be there definitely. So coefficient variation formula is that mean divided, so this is nothing but the relative measure. Okay, with respect to mean, how much the standard deviation. So standard deviation divided by mean, and if you are multiplying with 100, you are going to get with respect to in terms of percentage. If you are multiplying with 100, then you are going to get it in terms of percentage. So standard deviation divided by mean into 100. So we'll see there is one example here. So the score of 2 cricket players, okay, during a certain season. So these are the scores of 2 players are there. Okay. Now question is that, so how many innings they both played? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 innings each of the player has played. Now question is that which player is more consistent? So you can see whenever there is any cricket match, every batsman, they are scoreboard, what is that? Their individual record used to be displayed. Okay, so in that individual record, what it used to be displayed? So they used to display number of matches the player has played, what is its average score, and another one is the, what is that called? That terminology I'm missing. One is the average, another is the what is that? Okay, silly. So here two players are there and they have played 10 innings. Okay, each of the player has played 10 different innings. Now question is that which player is more consistent? Question is that which player is more consistent? So what does the consistent mean? How will you define the consistent? So for example, I'm calling for example, one is the batsman Rohit Sharma, another is the Virat Kohli. Okay, so Rohit Sharma, one match he scored 100. Okay, next match he scored 20. Another match he got 5. Okay, so whether Rohit Sharma will be called consistent, whereas there is another batsman Virat Kohli, he scored 50, next match 45, next match 55. So who will be called as the consistent? The first one Rohit Sharma or the Virat Kohli?
The Virat.
Kohli.
Virat Kohli will be called as the consistent. Why? Because he, what is the, so this may not be proper example. So you consider both are having almost same mean. Okay, both are having x1 bar and x2 bar. For both batsmen, mean is same. So how will you calculate the consistent? From which terminology? So whether mean will define the consistency?
No.
No, sir.
Mean cannot represent the consistency. Clear or not? Because in exam, many students, they used to calculate the mean and they used to say that, okay, so average is the batsman A average is more than batsman B average. So that is why batsman A is more consistent. Can you say the batsman is consistent depending on its average or the mean value?
No, sir.
No, sir.
You
sir.
cannot say. So how will you say that which batsman is more consistent? By calculating the deviations. So here for the first case, there is so much deviation is there. See, when the one batsman score 100, so you will expect the next match he will also score near to 100. But see how he has scored. He has scored 20. So this is below expectation level. So he cannot be called as the consistent batsman. But here the batsman, he has scored 50, next match also close to 50. Okay. So how will calculate the consistency or not? How? By calculating standard deviation. By calculating variance or by calculating the standard deviation, you can find the which batsman is more consistent. So here you can see the two batsmen scores are given here. Okay. And so we need to find the variation from the mean position. So you calculate the total sum, divide by mean. So first batsman, the mean is average is 46. Second batsman, the average, the mean is 50. Okay. Then you find the deviation from where? From the mean position. So xi minus x bar, that is x bar is your 46. So these are your xi's. Okay. So xi minus x bar, that is 32 minus 46 is minus 14. 28 minus 46 is minus 18. 47 minus 46 is plus 1. 63 46 is 17. 71 46 is 25. Similarly, 14 minus 46 is minus 32. Now, these deviations, so someone can say that just will add these deviations, but thing is that if you are adding these deviations, see what you are getting. You are getting 0. So that means whether it is having 0 deviation? No, it is not having 0 deviation. It is having lot of deviation. So how do you calculate? So some cases for other formula you can take mod. For the standard deviation or for the variance, we need to take the square of the error. This is nothing but your error term. Okay, you need to take the deviation. you need to take the square of the deviation. So this is the square of the deviation. So here minus 14 square is 196. So all will be positive. There will be no negative term. So now the sum of the square of the deviation is nothing but 6500. How many matches he has played? 10 matches he has played. So that means in each unit for the each match, then how much average deviation is having? Square of the deviation, that means 650 deviation is there. Okay, getting or not? Similarly, for the second player, now the deviation is square of the deviation, average of the square of the deviation is nothing but 596. So, which is happening? So, you will go for less deviation or you will go for the high deviation. Which is more preferable to choose? The batsman is more consistent. You will go for
Yes.
less deviation. So where you are having less standard deviation, that you need to check. So if you need to calculate with respect to percentage, then you need to calculate the coefficient of variation. Okay. So from here, the variance, this is nothing but variance of the first batsman. This is nothing but the variance of the second batsman. Then from here, you can calculate the standard deviation. So the standard deviation of the first batsman is 25.5. Standard deviation of the second batsman is 24.43. So that means for the second player, the error is less and he is more consistent than the first batsman. And even with respect to the coefficient variation also, you can say that coefficient variation is deviating with 48.86% and the first batsman is deviating with 55.43%. So the second batsman B is more consistent. Correct or not? Is it okay? Same thing here. There is another problem here. Suppose that samples of polythene bags from two different manufacturers A and B are tested by prospective buyer for bursting pressure with the following results. So these are the bursting pressures are given, okay, and these are the number of bags it is having, okay. So two manufacturers. So the manufacturer A is having this number of bags, manufacturer B is having this number of bags. Okay. Now, which set of bag has the highest bursting pressure? Which has uniform bursting pressure? Which manufacturer's bag would be preferred by the buyer? Okay. Now, so you can see these are the nothing but the frequencies are given. Okay. So what you can see, these are the continuous class width is there, and okay, so you need to convert it to the continuous. This is discontinuous, right? So you can see how you manage. So you can manage it because you need to make this is discontinuous. You have to make it continuous. How you manage? So you can see the upper limit of the one class, okay, and the lower limit of the next class. You find the difference. What is that? 10 point minus 9.9. Then you have to divide it with that. Okay. So what you are going to get? 10 minus 9.9. What you are getting? 0.1. Then 0.1 divided by 10. How much? Divided by 2. How much you will get?
0.05.
Yes, so that is you need to adjust. So you need to shift that 0.05 to the lower limit and with the upper limit. Okay, so lower limit you need to decrease by that unit and upper limit you need to increase by that unit. So if you are doing, then we will get the continuous case. So you decrease the lower limit by that unit 0.05, 1.95, and upper limit you increase by that unit. So that was 9.9. Now it will be 9.95. Then here lower limit you decrease by that unit, upper limit you increase. So here the decrease, Here you have to make the increase. Okay, the same you have to do for every class interval. Now, if you're doing, then it will be continuous series. Okay, so continuous series is there. So when the continuous series is there, we cannot take the class interval. We cannot take the class interval xi. Now, xi should be a particular point. So you need to take, what do you need to take? What do you need to take? How will consider the xi in class interval?
Middle, sir.
By taking the middle point. So you take the middle point. So middle point is 9.95 minus 4.95 divided by 2. Then you add that. So what is the difference is there? Average of difference. Then you add with the 4.95. Okay. You'll find the that 7.45. So what is that? 9.95 minus 4.95. So what you will get? 9 minus 4. So 5. So that means this is nothing but 2.25. Correct now? This is nothing but your 2.5. 2.5 now. So 2.5 you need to add with the all the lower term, you'll get the middle point. So 4.95 plus 2.5. You're going to get 7.45 now. Hello.
Yes, sir.
Similarly, 9.95 plus 2.5, you will get 12.45. Here 14.95 plus 2.5, you will get these middle terms. Okay, just middle term. You calculate the middle term. Okay, so these are nothing but your xi now. These are nothing but the xi. So xi is there and its frequency is there. Xi is there, its frequency is there. So here what they have calculated, they have not calculated the what is that? The mean. They have calculated that this is the step deviation method they have done. So assume mean they have taken. Okay, the assume mean A they have taken as 17.45. You can go for the that assume mean method, or you can find xi into fy divided by n. Okay, here calculation will be little bit difficult, lengthy. Both methods are okay. So here the assume mean they have considered, that is a equal to 17.45. You can consider any value as the assume mean. Okay, so you take one value from here so that you will have one value as 0. Calculation will be little bit simplified. So both methods are okay. Which method you are preferable, you are comfortable, you can follow that one. So you can find the deviation. Okay, then you need to take the average deviation. Okay, so then average deviation, sorry, first you calculate the deviation, then you need to multiply with the frequency. Then you need to multiply with the frequency. So the deviation along with the frequency you need to multiply. So then you need to average it. So here you can see. So they have taken the step, the assuming method. That is why they have calculated a plus and they calculated. So like I said, you can follow any method. Okay, and they calculated and they got the standard deviation value as 4.88 for the first manufacturer, and coefficient of variation is 23.24%. Similarly, for the second bag manufacturer, same way, exactly same way, you need to find it, and you need to find the mean and standard deviation. So you calculate the mean, you calculate the standard deviation, you calculate the coefficient of variation. Now, from this question, you need to see which manufacturer bags would be more preferable, which is having the highest bursting pressure. So you can see here. So for the manufacturer A, the mean is 21, manufacturer B, mean is 21.81. The standard deviation here you are having 4.88. Standard deviation here is so much high, 7.07. So the coefficient variation here, since the average bursting pressure is higher for the manufacturer B, the bags of the manufacturer B is having the highest bursting pressure. So I will see that which is having the highest. So you can see from here on the mean. So for the mean, it is having the highest bursting pressure, and it is not complete. There are so many other things are there. So what are the questions? Which set of wax is having the high average burning pressure? Okay, average manufacture B, and which has more uniform pressure, and if prices are same. Okay, so thing is that here prices are not same. And which manufacturer bag would be preferable by the buyer? Which has more uniform pressure? Which has more uniform pressure? Uniform pressure means which is having the less standard deviation, that will have the uniform pressure, correct or not? Which will have the less standard deviation. So less standard deviation which is having? So the manufacturer A is having the less standard deviation. So manufacturer A is having the uniform pressure, correct na? Hello, hello, correct na?
Yes, sir.
Yes, sir.
Hello.
Yes, sir.